This is diagnostic review, note 2 on Pythagorean theorem. So the definition, the Pythagorean theorem. So in a right angle triangle, this only applies to right angle triangles, the sum of the squares of the two legs, and when I say legs, that refers to the two sides that are for the right angle, equal the square of the hypotenuse. Okay, and the hypotenuse is the longest side across from the right angle. So let's just look at this image here and label it so we can make sense a bit of that definition. So right here is the right angle. So we know, and if you see this little box, remember that refers to the right angle. We know that the hypotenuse is the one across from the right angle. So this is always going to be the hypotenuse. Okay, very important that is always labeled correctly. And then obviously the other two angles we're just going to call legs. It doesn't really matter which one you call A and which one you call B. What is important is the formula we used, the Pythagorean theorem formula, or the Pythagorean theorem itself, which is c squared equals a squared plus b squared. Okay, and I get that simply from the definition, right? It says the sum of the squares of the two legs, so sum means adding, equals the square of the hypotenuse. Okay, and the hypotenuse is always going to be c. So let's try a couple of examples here. Okay, so this formula is very, very important. You're going to need to know how to use it. So example 1. Find the unknown values and round to one decimal place. So the first thing I'm going to do here is start by labeling my sides, okay, because the hypotenuse matters, right? It matters what side that is. So I see my right angle here. I draw a line. I see that x is across. So I'm also just going to label that c because I know c represents the hypotenuse in my formula. Okay, again, the other two sides are going to be a and b, but it doesn't really matter which you label A and which you label B. Once I have labeled those side lengths, I can start by writing out my formula. Once I have my formula written out, all I'm going to do is sub in what I know. Okay, so C in this case is x. So you can change it and write x squared. I'm just going to leave it as c because I know I've already labeled that side as c. So c squared, we don't know what c is, but I do actually know what a is. A is 5. Okay, and I also know what b is. B is 3. Okay, so in this case, I'm solving for the hypotenuse. I'm solving for c. This is going to be the easier version of examples involving Pythagorean theorem. Okay, so now I'm going to use my calculator or use my head, whichever you can do. And I can simplify this further, right? I can do 5 to the power of 2. I know that's just 5 times 5, which is 25. And 3 to the power of 2, which is just 3 times 3, which is 9. So I have now, I can simplify this further, right? I can add those together. So 25 plus 9 is 34. Okay, and this is the part that you might forget. So I now know that c squared equals 34, but it's asking me to find the side length. So the side length is just c. So in order to get rid of that squared, what I need to do is I need to take the square root. Okay, what I do to one side, I have to do to the other. So the reason I'm taking the square root of the left side is because those are simply going to cancel out. Okay, so now I no longer have that squared there. So now I have c equals, and the square root of 34, I'm definitely going to need my calculator for that because it doesn't give me a nice number, but I type that in, and I get an answer of 5.8. Okay, 5.8 what? Centimeters, right? That's going to be very important to include. 5.8 centimeters. All right, and now we know the side length of side C. So let's look at another example. It's a bit trickier, but the same idea. So again, I'm going to start by labeling my sides. So the first thing I'm always going to label is the hypotenuse. I look at the right angle. I know across from the right angle is my hypotenuse, so I'm going to label that C. Always C, and then again, my A and my B don't really matter. Okay, so I'm going to write out my formula. C squared equals A squared plus B squared. Next step, sub in the information that I know. So this time I do know C. C is 7. A, I do know A. A is 6. And again, B is what I'm looking for. They call B Y, but it doesn't really matter. Okay, you can just call it B or you can change it to Y. Regardless, it's the variable that we need to solve for. Okay, next step, simplify this. So on your calculator, if you need to, 7 to the power of 2, or 7 times 7, which is 49. Okay, and 6 times 6, or 6 to the power of 2, 36, plus b squared. So when we're trying to solve an equation, right, our goal is to get our variable all by itself. So what I need to do is I need to get this 36 across the equal sign. So there's multiple ways you might know how to do this. One way is to put it over the equal sign and change the sign. Okay, so this was positive 36. If I move it over the equal sign, it would become negative 36. Another way to kind of look at this is, in order to get rid of it from the right-hand side here, I have a positive 36. Well, the opposite operation of positive 36 would be to subtract 36. So 36 minus 36 plus b squared. Okay, the reason I also subtracted 36 from the left side is because when I'm solving equations, what I do to one side, I have to do to the other. Okay, it's just a rule. It's the only way that we're able to actually do stuff like this. Okay, but 36 minus 36 is just 0, so those are going to cancel out. So I'm left with, oops, wrong color, 49 minus 36 equals b squared. So we're getting closer, right? We wanted b all by itself. We're almost there. So 49 minus 36 is 13. Okay, remember this is the tricky step, or the trickiest step in this. When we have something squared, to get rid of that squared, we're going to take the square root, which means those are going to cancel. But what I do to one side, I have to do to the other. Okay, again, the square root of 13 is not going to give me a nice whole number, so I'm going to need to use my calculator. So my final answer, I get b equals 3.6 centimeters. Okay, so the only reason this one is a little bit trickier is because we have to do some rearranging, whereas the first example here, we already had C all by itself or isolated, so we didn't have to do that rearranging. Okay, so this is lesson 2 for review on the Pythagorean theorem.